Sharks, despite what many people think, are not only apex predators that live in groups. In fact, there are more than 500 species of sharks, and they have evolved to live in all oceans across the globe. And throughout evolution, they've developed different strategies to hunt prey and survive. One such shark is the hammerhead, so named because of its unique head shape, which is also known as a cephalofoil. This morphological adaptation gives them several advantages when it comes to hunting prey. But being solitary hunters has its drawbacks. Hi, I'm here to tell you about the strange ways hammerheads get their dinner. The name hammerhead refers to 3 very distinct species of shark, each with their own preferred habitat. The great hammerhead lives in the open ocean and prefers tropical waters. Scalloped hammerhead tends to hang out in shallower coastal waters, and the lesser hammerhead is generally found in the warmer waters of the Pacific coast of the Americas. All 3 of these animals are classified as vulnerable by the International Union for Conservation of Nature. Although they're currently doing okay, scientists predict that by 2022, we could see all 3 species disappear from our oceans. Okay, so let's talk about this head shape. Sharks have been around since before the dinosaurs. And at some point during their long reign over the seas, someone decided that a normal pointy nose just wasn't good enough. So they began growing heads like hammers. This is a great example of convergent evolution, where unrelated organisms independently evolve similar traits because they live in similar environments or have similar lifestyles. Hammerheads aren't the only ones with this head shape. There are also the shovelhead and the winged head shark, both of which are in the same family as the hammerhead. They all adapted this morphology separately. It's still unclear exactly how this head shape helps the sharks hunt, but they all seem to prefer similar habitats and prey. For example, the great hammerhead tends to hang out in the open ocean, far away from land. This is called the pelagic zone, and it's also where you'll find the whale shark and the basking shark, 2 of the largest living sharks. The great hammerhead can grow up to 6 meters long and weigh more than 1,000 kilograms. That's nearly twice the size of a human. It's no small shark. But despite their large size, they're surprisingly graceful swimmers and can reach speeds of up to 46 kilometers an hour. They're not fast enough to chase down a seal or a sea lion, but they don't really need to be. You see, the great hammerhead is a filter feeder. Like the whale shark, it swims with its mouth open, filtering plankton and small fish out of the water column. This is pretty different from other hammerheads, though, because the other 2 species are apex predators. When the scalloped hammerhead is out hunting, it feeds primarily on stingrays, but also eats crustaceans, mollusks, and fish. The lesser hammerhead mostly eats crustaceans. Now, thanks to its flattened head, the hammerhead has binocular vision, meaning that both eyes are on the front of its head and face forward. This gives them excellent depth perception, which is useful when looking for prey buried in the sand or hiding among coral. Not only does this head shape allow for better vision, but it increases the animal's surface area, which means it can sense subtle changes in the movement of the water around them. These sensory inputs help the shark quickly determine if what they're looking at is actually food instead of just a rock or a clump of seaweed. Plus, their wide-set eyes mean that they have a huge field of view. The great hammerhead has eyes on the sides of its head, giving it almost 360-degree vision except for the blind spot right behind it. Now, most sharks have nostrils at the front of their head, but the hammerhead has theirs at the very tip of their nose. This might seem like a disadvantage, but it allows the shark to smell prey hidden under a layer of sand or detect chemicals released by injured animals without having to swim right up to them and potentially give their position away. But maybe the best part of the hammerhead's head is the electroreceptors called ampulla of Lorenzini. These are the little pores you see all over the front of the shark's head. They contain a special kind of cell that detects even the faintest electrical signals generated by other animals. Basically, they're able to sense the heartbeat of prey hiding in the sand or buried in the mud. The great hammerhead has the most densely packed receptors in the middle of its forehead. While the other 2 species have more receptors along the edges of their head, the distribution of these receptors might be related to the habitats these sharks prefer. The great hammerhead lives in deeper, darker waters, so its more sensitive receptors help it find prey in low-light conditions. These incredible senses allow the hammerhead to hunt alone without the help of its shark friends. Being a solitary hunter has its benefits. Each individual gets more prey and there is less time and energy spent on group activities like defending a shared territory or finding mates. But it can also be dangerous. Hunting alone means you have no backup when things go wrong, and hammerheads often end up getting injured while trying to capture prey. Even though they're apex predators, hammerheads sometimes fall victim to other animals. Several species of fish, including the oceanic white-tip shark, are known to scavenge dead hammerhead carcasses. Even hammerheads themselves will cannibalize dead hammerheads. One study found that of the 14 stomachs they examined, 10 contained hammerhead vertebrae and vertebrae from other species of sharks. Another problem with being a solitary hunter is that you might miss out on crucial information about your environment. If a group of sharks are schooling together, each individual can cover a larger area and therefore be more vigilant for danger. A lone shark is more likely to be injured or killed. And this seems to be the case for the great hammerhead. Their injuries often appear to be from other sharks, especially tiger sharks and makos, which are also found in the open ocean. Now, it's important to note that although these animals can be found in the open ocean, they're not actually swimming around in the middle of nowhere. The pelagic zone isn't just a big blue nothing. There are entire ecosystems thriving in this part of the ocean. The open ocean is home to gigantic schools of fish and massive squid and jellyfish blooms. The great hammerhead is perfectly adapted to take advantage of the prey available in this environment. Its huge head allows them to efficiently filter tons of water to find food, while its electroreceptors help them locate squid and other prey in the dark depths. The great hammerhead doesn't need to be around other sharks, because there is plenty of food to go around. Well, at least there used to be. Overfishing and habitat destruction have taken a major toll on the great hammerhead population. Between 1990 and 2001, the global catch of great hammerheads increased from 8,000 to 80 million per year. By 2010, 97% of the global population had been caught. And hammerheads aren't the only animals impacted by human activity. These solitary hunters rely on a variety of senses to find food and avoid being food. These senses have allowed them to thrive in their environment for millions of years. But as our planet continues to change, these magnificent creatures may become a thing of the past. So next time you're watching a nature documentary about sharks, look out for the solitary hammerheads. They're truly remarkable creatures who prove that you don't need a bunch of friends to survive. Hammerhead sharks are truly unique animals, and we hope that they continue to swim the oceans for millions more years. Thanks for watching this episode. I've been your host. See you next time.